for us to take you through our Net 303 session, which is on network segmentation and inspection, and in particular, just focusing on the transit gateway and Cloud WAN concepts and how you can achieve proper scalable network inspection on AWS. So just a quick agenda. We'll go through the basic architectural constructs because it's important to have the right foundations. And then I'll walk you through how to do some proper network segmentation. Then later on, Ashraf will walk you through traffic inspection and how the two AWS capabilities, Cloud WAN and AWS Transit Gateway, help you achieve that. All right, so I think it's important before we discuss the inspection to first just walk you through the relevant architectural constructs that we have on AWS that help you build proper networking foundations. So how do we have this in place, right? So if you think about the AWS regions, AWS availability zones, you could have deployments that sit either in one AWS region or another AWS region, right? Multiple AWS regions. You could have deployments within the same region for different parts of your application. So you have a construct sitting, let's say, on VPC1 or another one sitting on VPC2. You could have scenarios where you need to have these resources that are sitting across different regions talk to each other. So, with that in mind, you want to sort of have the right building blocks that help you start right to eventually achieve, proper security, traffic inspection, depending on whether you're doing, a VPC to VPC inspection or internet to VPC inspection or, something coming from your on-prem data center to AWS. So like I said, let's just think about traffic coming from the internet back to resources that sit on AWS. So you're thinking about, let's say you're running a software as a service product coming through the internet. You want to inspect that before you hit a backend that sits inside a VPC. That becomes, a supported capability. But then even more importantly is we have traditional systems that sit in branch offices, that sit in on-prem data centers, and you need to think about how to bring that together. So just to make sure that at least we give you the right breadth of capabilities, think about you already have an existing software-defined one sitting in a branch office. AWS provides you the capabilities to do SD-WANs using third-party appliances. Think about existing tool sets that you might have. So you can extend your SD-WAN to AWS into a VPC, connect to resources that sit on AWS. Think about maybe a site where you're doing IPsec, or you're more established organization and you have large data centers that you want to connect to AWS using hybrid AWS constructs like Direct Connect. Think about MPLS networks that you want to extend into AWS. Think about today, where people are able to work from home, and you want your team to either access remote desktops that are running on AWS, in this case VDIs. AWS provides you that kind of capability, and the foundations for that, and later on my colleague Ashraf will cover it, is in the construct of a transit gateway or an AWS Cloud WAN construct to actually help you bridge the gap between your on-prem data center and AWS. And even more importantly is you think about you have resources deployed in multiple AWS regions, right? You say you're trying to do a highly available deployment. Maybe you've got a business continuity plan that requires you to do multi-region deployments. How do you get still, resources talk to each other, just in case you're trying to replicate something and so on and so forth? I mean, the AWS Transit Gateway, for example, allows you to do, cross-region peering so that you can connect these two regions. But that's just one way to do it, right? Even a simpler way to do it is to just use Cloud WAN, which is a global construct that allows you to connect your different regions regardless of how many you're using, and have your resources in different VPCs, in different EC2 instances talk to each other using the AWS backbone without you having to rely to third parties. All right, so I think that's just a little bit broad, right? But more specifically, I think it's important that I focus on the common patterns that we see, right? That is probably what we are trying to do today in our organizations, where we've got single region deployments, and it's a case of maybe I have a front end deployed in one VPC in either serverless or compute driven, and I have a backend maybe in a database deployed in a different VPC, and I want to do sort of, either intra-VPC or inter-VPC communication, depending on how I've done my deployment. Or even within a VPC, for example, if I'm doing, say, a load balanced solution, right? I have a load balancer that spans across, multiple availability zones, and I'm trying to sort of just, have this communication happening. So that's a common pattern where we see, deployments where you want to inspect traffic as it moves from one server, let's say a front-end server to a back-end server, and you want to see what's going on there. So that's a common pattern that we see. The other one I'd mentioned is you're trying to do, let's say, front-end in one VPC, back-end in a different VPC, because maybe security requires to do that kind of thing. Maybe you've got a compliance requirement that requires you to separate function and create very logical boundaries that you can actually demonstrate. Again, you're thinking about an east-west kind of traffic inspection. In this case, like I said, again, you choose to deploy an entire front end in one VPC, and you choose to deploy your back end in a separate VPC. That's another pattern that we see. It's common. Most of the time, it comes from security, and you want to create boundaries. So for you to achieve that, you're able to do that, and then you can do effective, fine-grained inspection of your traffic across VPCs. But even more interestingly is the other pattern that we see. Business continuity requires you to do, yes, you deploy one primary instance of your application in one region, but you need to have a smaller version, a light version of your application in another region, because you need to be able to quickly recover, do disaster recovery, at an instance. So for that, it's, region A to region B, and that's sort of, inter-VPC. It's a pattern that we see. And for this, like I said, it depends on your maturity, where you're coming from an organization, the security guidelines that you have in your entity that, you need to demonstrate. So being able to do that, AWS supports that. We have constructs like VPC peering, but, that becomes not scalable if you've got this going into hundreds of VPCs. So how do you effectively collapse that and achieve a seamless integration? This is where, the constructs of Cloud WAN, Transit Gateway, to collapse your network, and I'll show you those architectures shortly, come into place, right? And before I forget, again, on-premise to a single region or a multi-region kind of reach, how do you do that? Maybe using something like a VPN or using something like Direct Connect. Supported architecture, common patterns that we see where Cloud WAN, Transit Gateway come into play. All right. So I think it's good that I zoom in just a little bit on Matters network segmentation and how that is achievable. Now, that assuming that you've said, okay, fine, mine is VPC to VPC or region to region or on-premise to AWS region. The two constructs, Transit Gateway and Cloud WAN, help you achieve connectivity to AWS and simplified connectivity into AWS. And more importantly, if you think about traditional network setups where you've got VLANs, you've got either VRFs if you're running an MPLS network, and you've got segmentation for, let's say, your dev environments, test environments, production environments, because you need to demonstrate that, right? And you want to extend that into AWS, right? Carry the same boundaries into AWS. The construct of Transit Gateway and AWS Cloud WAN helps you to achieve this. And how do you go about it, right? So in AWS, either in Transit Gateway or AWS Cloud WAN, you're actually able to do this at a route table level, right? Where you can have route tables specific for, let's say, your production environment. You have a route table specific for your test environment. You have a route table specific for your dev environment. And in this way, as you're extending your infrastructure from, your on-premise setup to AWS, you can create those segments that help you keep, traffic isolated, achieve the kind of security requirements that you have as a business, and, just make sure you have the right guardrails in place. So how, you're able to do this, like I said, in AWS, over and above the route table construct, you again can actually take it to a VPC level so that you've got a production VPC, a test VPC, and a dev VPC, right? Because then down the line, you can actually bind a route table to a specific VPC, giving you that flexibility to achieve that kind of separation. Now, on the extension of on-premise to AWS, right? With this, you're talking about using either a site-to-site IPsec VPN, or if you're a larger enterprise, you are using something like Direct Connect, right? which then helps you, leverage either dedicated lines or just the internet to extend your connection to AWS. Now, let's just keep that aside and think about it before these constructs existed, right? Where let's say I'm a corporate global network and I have all these environments in AWS where I've separated production, I've separated test and dev, and I'm trying to connect from on-prem to AWS. It would require you, let's say if you're trying to do a redundant kind of setup, to create tunnels to each of these environments. So if you're thinking about, just say, a case of 1, 2, 3, 4 VPCs, right? And you're trying to come from the corporate data center, you're talking about probably about 16 tunnels to just achieve connectivity between your on-premise network and AWS, where you want to also keep the separation of production environments, test environment, and dev environments. So you're having to create specific tunnels for each one of these environments, which, if you think about a more larger deployment, is not scalable. It's an operational overhead, and probably not the best experience for your network engineers. And to sort of help you simplify this and avoid having to do that management overhead, AWS actually, brought in the construct of the transit gateway or the cloud one, right? Because then with this, I just need to create one set of tunnels to either cloud one or transit gateway, and I can attach the rest of my VPCs to this transit gateway or cloud one setup to simplify the number of tunnels I have to build. In this case, as you can see, I'm only doing 2 for each environment, reducing the number of tunnels that I eventually have to build for the same setup. We come from 16 to about only 8. Actually, it's about 6 tunnels in this case to connect all these 3 different environments that I had in place. What this actually helps you do is, from a management overhead perspective, is there's lesser resources for me to look at. There's fewer places where things could go wrong. If I'm having, let's say, a monitoring team, I can just reduce the number of resources that I need to have in place to actually keep an eye on my network setup, my network foundations, and eventually assure the business that I'm having the kind of setup that is scalable depending on whatever number of applications we need to migrate to AWS. Eventually, I can just use this basic foundation to attach whatever number of environments I'm going to have in place, because the only thing that you start changing actually is on the left, which is the VPC attachments that you're seeing there. If I have a new environment, I just bring it up in a new account, share the transit gateway or the cloud one, attach my VPC. I already have a relevant route table, and I'm good. I'm good in terms of connectivity. So that's just on the IPsec side of it, right? So think about someone who's trying to do direct connect, and direct connect has different flavors, right? You either have a dedicated connection or a hosted connection. Depends on either the kind of throughput you require, or where in the world you are, because in some places we have direct connect services available, and in some places you have to get it through a hosted connection. So with this in mind, like I say, different ways to connect to AWS. It can either be a private VIF, which is a virtual interface where I'm connecting my private networks. So it's a dedicated connection. Only my networks can talk to each other on-prem and public. On-prem and AWS region. And again, while I have, of course, direct connect in place, I can also back this up with IPsec tunnels, right? So let's say, for example, I want to do my test using direct connect. I want to do production using, direct connect transit VIF in this case, but I want to also create a backup of this, right? In the same principles, I can actually run, an IPsec tunnel over this direct connection, and have a site-to-site VPN that is private, that is not reliant on the internet. Again, a different separation. I want to do a dev environment, same thing, a hosted connection or a dedicated connection, and then back it up with an IPsec tunnel, getting the constructs of, transit gateway, cloud one to collapse these setups. Okay, but even more importantly is, like I said, you can exist in one region, but what about if you exist in multiple AWS regions? How do you then rely on AWS's network infrastructure to scale your, backbone connectivity between your regions, and simplify that without you having to rely on third parties to actually connect multi-region deployments? Like I said, it could be direct connect circuits, or they could be site-to-site VPNs, but therein enters the construct of AWS Cloud WAN, which is you relying on AWS's global network to build your backbone network. So again, corporate data center, I have, of course, the constructs of direct connect gateway because I'm trying to do direct connect, terminating either on transit gateway or terminating on AWS Cloud WAN. And then instead of the traffic going through my third-party carriers, that traffic can actually move from one region to the next region using the AWS backbone, using the AWS Cloud WAN. And in the Cloud WAN, I can actually create separate network segments. So I can extend, let's say, for example, production VRF. In this case, is virtual routing function, all the way to transit gateway, all the way to a development segment sitting in my AWS Cloud WAN deployment, and then now extend that dev segment between region A and region B for any other resource that sits in region 2 that is a dev resource. Simplify my setup using more reliable connection because AWS is providing you with that, and you don't have to worry about things like throughput because we take care of that behind the scenes. And in that case, I can connect multiple corporate data centers to the AWS region, in a similar fashion, right? By extension, then scaling what I'm able to do in terms of anything that might require, a back-end connection between resources that I deploy in region 1 and region 2. Instead of relying on, third-party connectivity, I rely on AWS connectivity to do this kind of setup. Again, separate, create, different segments, either in the Cloud WAN or in route table specific in the transit gateway to create those separate segments. Right. I think it would be not enough not to speak about other ways of, extending your connectivity still to Cloud WAN, transit gateway, for, sort of environments where you've got production, dev, test kind of setups. And in this case, I'm thinking about, SD-WANs, network overlays that I'm trying to extend, maybe a layer 2 network because probably my application requires me to have a layer 2 network, or, something of similar fashion. So if you're thinking about an SD-WAN, the AWS Transit Gateway and Cloud WAN actually allow you to extend GRE tunnels. So you can extend your SDN network all the way to AWS Cloud WAN, all the way to your Transit Gateway, helping you achieve, an extension of your MPLS network or SD-WAN network that you already have in place into AWS and separate the environments again, either in, at a VPC level, using, like I said, segments in Cloud WAN or route tables in Transit Gateway. I think that is important because it gives you kind of an idea of just the foundations, because with those foundations, then you can start thinking about, okay, how do I introduce the aspects of traffic inspection, depending on whether it's, north-south kind of inspection, whether in that case it could be something coming from on-prem, coming to the internet, could be an east-west inspection, that is something coming from one region to another region, or something coming from one VPC to another VPC, depending on how you've separated your setup. And the architectures could be as extensible as your business requires. That's something we can discuss. After this session, if you have something specific that you're trying to do, but most importantly, is just to reiterate the capabilities of the AWS Cloud WAN and Transit Gateway to be flexible enough to take traditional connectivity in terms of things like IPsec tunnels, direct connect circuits where you can do BGP, but also extending, your software-defined wide area networks onto AWS without you necessarily changing, some of the already investments that you have in place and achieve, properly segmented, well-designed network foundations that allow you to then migrate complex workloads into AWS with very specific security requirements, compliance requirements, and governance requirements. And with that, foundation bit, I'd like to introduce my colleague Ashraf to come and walk you through the inspection concepts that you can then build on top of the underlay setup. Thank you.
Thank you, Joseph. You can hear me, right? Okay, awesome. So let's build up on what Joseph was talking about from an inspection perspective. We spoke about different network topologies that we can build with AWS, but now we want to see how this traffic can be inspected. So I want to go again about some of the patterns that Joseph spoke about. We spoke about inspection the traffic within the same VPC. We might need to have some sort of inspection between, for example, a subnet which has my application layer to my database within the same VPC. which also we call east-west. What can be also considered east-west traffic, which is between my own infrastructure, is applications running between different two VPCs, right? A lot of customers, they decouple their applications per VPC. So that's also traffic that I need to inspect. Another type of inspection that I need to do, if I go global, I have VPCs in multiple regions, and then I need to inspect the traffic between them. I still consider also that east-west because it's within my infrastructure. Then I look at north-south traffic, where I have, for example, on-prem workload, hybrid connectivity to AWS. I also need to inspect that traffic. I also need to inspect the traffic going to the internet and also coming to my workload, right? So a lot of things to think about from an inspection perspective. And from that, we're going to talk about the concept of a global a gateway load balancer, right? If you didn't hear about it, before we introduced gateway load balancers, when customers wanted to run appliances to do deep inspection to their traffic for east-west or north-south, depending on the type of traffic, they need to run like a third-party appliances that, for example, they get it from the marketplace, they deploy it in their VPC, and they start inspecting the traffic. And they can use any of the topologies that Joseph was talking about on how to connect all the VPCs. It was a bit of a challenge how to keep availability of these services. Like if you have a firewall running on one EC2 instance, you need to make it highly available. So you need to think about how to keep it available. Different appliances work in a different way. So we introduced the gateway load balancer. Gateway load balancer, basically from the name, it's a load balancer between different appliances. Instead of running my firewall, for example, in active passive, I can run two different nodes in two different availability zones for high availability. I can have a VPC with these appliances. I will call it an inspection VPC. And then I can have that gateway load balancer in front of these instances. And to connect to it, in the same VPC, I can create what we call a gateway load balancer endpoint, where I send the traffic to it, and it will send it to my appliances. So it gives me this capability to have a highly available firewall to my VPCs, right? And then to remove some of this overhead from our customers, we introduce our managed on network firewall, which is called network firewall, right? So network firewall is like our managed firewall that you can put in your VPC. You can use it for centralized inspection between VPCs. It's fully managed by AWS. You don't need to worry about its scalability. It provides you with this intelligent security capabilities and apply policies within your infrastructure in AWS to inspect all this kind of traffic. So network firewall, remove that overhead. And we use the same technology that we provide to our customer when they want to run third-party appliances. But we changed the name because it's a managed service. Instead of calling it a gateway load balancer endpoint, we call it a network firewall endpoint, where you can also deploy it in multiple availability zones for high availability and connect it to your network firewall. So it uses the same concept. So whatever we talk about it for a gateway load balancer and appliances, it's the same for network firewall. So now, when we talk about how I can deploy these firewalls in my own infrastructure, there's different topologies on how I deploy these things. So I can use, for example, distributed inspection. What do I mean by distributed inspection? I have different applications. They don't need to talk to each other. There's no need for communication between them, but I need to inspect this traffic, for example, for north-south, right? Or maybe there's need some inspection between the different subnets. Like I mentioned, it's also considered east-west. Distributed, meaning that I will have a separate firewall in each one of these VPCs. I will have different resources for it. So I have my workload in one VPC. I will have the network firewall in it, and then I will inspect the traffic in that perspective. That means that if each workload run individually, I need to manage these policy for each firewall individually. Different firewall means different rule groups, different type of traffic that I need to inspect. If my applications speak to each other, and I need to inspect traffic between different VPCs and also for north-south, then I go to centralized inspection. Here, I will rely on what Joseph mentioned. I can rely either on transit gateways or Cloud WAN to connect all my VPCs within a region and globally. I can also connect my on-prem to it, and I can have a centralized VPC where I can send internet traffic through it through a NAT gateway, for example. So in that perspective, I can have my firewall, for example, in one inspection VPC. My firewall endpoints, my firewall load balancer will be there, and my firewall exists there. It's highly scalable, like I mentioned. I can connect all these VPCs through my transit gateway and Cloud WAN, and then when I send traffic between them, When I send it, for example, through Transit Gateway, it will send it first to the network firewall, get inspected, then send it to the destination VPC. Same thing when I send traffic to on-prem and the internet. So everything goes through one centralized network firewall, meaning that I can centralize my policies, I can enforce it in a global perspective, I can manage these rules centrally also, and I can apply my security measurements in my entire infrastructure. So this is a centralized inspection. But then I might need both. I might need to inspect traffic for everything, and I might need, there might be some regulations or security requirements where I need to have a separate entity for certain traffic for certain workloads. So I can have distributed deployment and centralized deployment for my traffic, depends on what I need to inspect there. So it's not like I need to have distributed or centralized. I can combine the two depending on my needs, right? And this is the beauty when we talked about the different topologies that Joseph was talking about, which when we build this global infrastructure and when we create this segmentation, for example, using Cloud WAN, I can create this global infrastructure, I can have my workload distributed globally, but I can still centralize the inspection between them. When I want to go from region 1 to region 2, for example, I have a production segment, I have a development segment, I have shared services, and so on, I need to make sure that I inspect the traffic between these segments. Even when I'm within the same segments, I also need to inspect the traffic between them. So it's a lot of things to talk about, right? So I need to be able to deploy security policies with it. And we spoke about all this topology and how I connect all these pieces together using Cloud WAN. And this is the beauty of it. Like when I use Cloud WAN, I can centralize everything through, I can do centralized inspection in one region before I send the traffic to another region, and I can inspect it again in a different region. So I can do the inspection in 2 different places, right? Which is also increase my security posture here. Same thing I can do with the transit gateway. If I have different VPCs, we spoke about it, simplest way to connect them and scale is using either Cloud WAN or transit gateway. Transit gateway works in one region. I can connect all these VPCs together with the transit gateway, and then I can have one VPC, for example, for inspection. And recently we even removed that requirement from customers to have that inspection VPC. You can create multiple availability zones with your transit gateway and have your network firewall endpoints in it. So you don't even need to have that inspection VPC anymore. You can send the traffic to the transit gateway. The transit gateway, in an appliance mode, it will encapsulate the traffic with Geneva packets, send it to the network firewall, get inspected, then it will send it to the destination instance or VPC, right? And then this is when we talk about route segmentation and centralized inspection. And just to show the comparison between when to use transit gateway and when to use Cloud WAN. Transit gateway is good if we deploy our workload in one region, right? If I have more than 3-4 VPCs, I can go with a transit gateway because I can use VPC peering, right? But the problem with VPC peering, it doesn't support transitive connection. So I need to have like a full mesh topology between all my VPCs. So it's more to manage and to think about. It's not that good when you scale. So when I have more VPCs, then I start thinking about transit gateway. The transit gateway is regional, so I need to have transit gateway per region. If I want to connect the regions, I need to have peering between these transit gateway. Now, when I want to think about it from a scalability perspective and a global perspective and how easy it is to integrate a new workload, segmentation transit gateway works on an attachment level. I can have different attachments for different workloads, and I can have different route entries for it. Cloud WAN, you can create this segmentation and you can have automation with your network topology. So it will be easy also to add an application and a new VPC and just ingest it to the right segmentation, right? So it's easy to scale it even within the same region. And also globally, because that segment can span over a region. So when Cloud WAN first came, they were talking about what is a global VPC. Global VPC meaning that I have a /8 that I use in all my regions, and then I can have one segment connecting all the VPCs to it, which means I can route globally between these VPCs, which means I can actually have one network with everything. But I can have different segmentation for it, and that's a nice thing about Cloud WAN. And I can do centralized inspection with it, right? And I can have also the combined topology, because it allows me also to do all this inspection within that network, my global network. So just in comparison, when to use Transit Gateway to Cloud WAN. Transit Gateway, it's managed by the customer, it's regional, it's good when you want to scale between a few VPCs, and when you add one VPC to another VPC in the same region, you need to do the whole configuration. You need to go, for example, build automation and deploy the same automation in a different region and configure all that and peer the two transit gateways together. Cloud WAN is managed by AWS. It's a global construct, like I mentioned. You can have this core network edge. You can apply policies to it. It's easier to automate and ingest new VPCs and workload to it. So it's easier to scale globally. So you can have the two options and think about your workload and how you want to scale. Even from a cost perspective, at some point, Cloud WAN can be cheaper even than Transit Gateway. Great. So I think that was the last slide, and hope you enjoyed the talk. That's about it.